Hello Klimani, welcome to today's video lesson. I'm going to make two videos. The first one covering trig quadrants and the second will be on plotting trig graphs. You'll find these sections starting on page 101 of the textbook. So just to refresh, our trig ratios, sine, cos and tan. I've made up a little rhyme here, so, car, toa. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So just to refresh on our quadrants, we have four of them. First quadrant, second, third, and fourth. So each of these quadrants has size 90 degrees, and when we go around in an anti-clockwise direction, we make a full rotation, 4 quadrants, 4 times 90, 360 degrees. So now I just want to plot our triangle in each of the quadrants using the notations hypotenuse, opposite, and adjacent, and I want to show you how the signs of each of these ratios vary as we move from quadrant to quadrant. So remember, for this story, we start off with a hypotenuse at 0 and we move anti-clockwise 1 full rotation. The hypotenuse is always positive. We have opposite, adjacent, relative to our angle theta. For the first quadrant, opposite is positive because it's above the x-axis, and adjacent is positive because it's to the right of the y-axis. In the second quadrant, hypotenuse remains positive. Opposite remains positive because it's above the x-axis, but adjacent now changes signs because it's to the left of the y-axis. Next, for the third quadrant, we have opposite changing sign, hypotenuse remains positive, and for the last quadrant, we have adjacent staying positive and opposite becomes negative. So how does this impact our trig ratios? Let's start off with all the ratios that are positive in each quadrant. For the first quadrant, opposite is positive and adjacent is positive. Hypotenuse is always positive. So all ratios are positive in this region. For the second quadrant, we have only opposite as positive. Opposite and hypotenuse is positive. There's something coming up here on my computer. Opposite is positive, hypotenuse is positive, adjacent is negative. So the only trig ratio which would be positive here is sine of theta. Okay, so just let's refresh what's happening to theta as we move from quadrant to quadrant. So for the first quadrant, we sit there, the second quadrant, third quadrant, and fourth quadrant. So for the second quadrant, sine of theta is going to be the sine of this whole angle. Okay. By definition, our ratio tells us so, opposite over hypotenuse, and in this case the opposite is positive, so the whole ratio is positive. Let's check for the other two ratios, cos and tan. So cos of theta is adjacent over hypotenuse, but in this case our adjacent is negative. So it's negative a over h, and that means this whole ratio is negative. Okay, we can similarly check for tan of theta. equals opposites over adjacent. So our opposite stays the same, it's positive, but our adjacent is negative. So this whole ratio is negative. Okay, so I'm not going to go through the rest of them for each of the quadrants. I'll just write it down and you can double check using SOHCAHTOA. For quadrant 3, tan is positive, sine is negative, cos is negative, and for quadrant 4, cos is positive, sine is negative, and tan is negative. Okay, now I just want to discuss a few of the angles with you. These are going to be angles greater than 90 degrees, so angles outside the first quadrant. In previous theory, we've been comfortable with working with acute angles, but now we need to, for plotting the trig graphs, when the angles go from minus 180 to 180 or 0 to 360 as our domain, we need to know how to work with obtuse angles. So let's take a look at an example. So we need to see what's happening with cos of 120 degrees. So that would be in our second quadrant, 120. So if the size of this angle is 120, this missing piece will be 60 degrees because of sum of angles along a straight line being supplementary. So in other words, cos of 20 is going to be the same as cos of 60 degrees, but because we're in the second quadrant, cos is negative. So all we need to do is relate the obtuse angle to some acute angle as our first step, and the second step is to check the sign of our overall ratio. Let's look at another example. Sine of 210 degrees. So 210 degrees is greater than 180 degrees, less than 270 degrees, so it lies in our third quadrant. If we were to draw this angle, we've got 180 plus 30. So this little angle is 30 degrees. We have our negative, opposite, negative, adjacent hypotenuse. So when we relate this 210 to an acute angle, we're going to say it's the same as sine of 30 degrees, and in the third quadrant sine is negative, so we have to change the sign of our overall ratio. Okay, last little example, we're going to check tan of 210 degrees. So remember, 210 degrees was in our third quadrant, and our acute angle that we related it to was 30. So this comes out to tan of 30 degrees. And because tan is positive in the third quadrant, we don't need to change the sign of our overall ratio. It just stays positive. And now we can just double check our final answers. So if you were to type in cos 120 on the calculator, you get negative a half. And if you type minus cos of 60 on the calculator, you get the same thing. For this ratio, you would get negative half, and for the last ratio, tan of 30, let's just check with our special angles. Got 60, 30, 2, 1, root 3. So tan of 30 is 1 over root 3. Your calculator will give you the ratio, will give you that in decimal points is 0.57735. So I'm just leaving it as a fraction. Okay, so that concludes this first video, just on quadrants and angles which are obtuse. And in the next video, we'll see how we can plot these angles and get a graph for the trig ratios.